So what if the search for aliens wasn't some top secret thing happening in a hidden lab, but right there on your own computer? Well, for over 20 years, that was the actual reality for millions of people. This is the incredible story of SETI at Home, the project that basically turned all of our homes into one giant planet-sized telescope. It's probably one of the biggest questions we've ever asked ourselves. It's what makes us stare up at the night sky and just wonder, is anyone or anything looking back? But actually finding an answer? Well, that is a monumental task. The universe is just unbelievably vast and incredibly noisy. Any potential signal from another civilization would be so faint, completely buried in this huge sea of cosmic background noise. So to really wrap your head around the challenge here, you have to appreciate the sheer scale of what we're dealing with. It's not just like looking for a needle in a haystack. We're talking about looking for a very specific, tiny needle in a haystack the size of the entire cosmos. Think about it like this. The universe is just constantly screaming with random noise across every frequency imaginable. Now, an intelligent signal, we think, would probably be a very specific, narrowband transmission, trying to pick that one little thing out of all that chaos. Well, it's a signal processing challenge of truly epic proportions. The scientists behind the search for extraterrestrial intelligence, or SETI, they just knew. They couldn't crack this problem with the old methods. They needed something totally new, something revolutionary. And that's when they came up with this brilliant, kind of out there idea. What if, instead of trying to build one single massive supercomputer right at the telescope, what if they could just borrow a tiny little bit of processing power from millions of regular computers all around the world? Okay, so the absolute genius of this whole system is laid out right here. It all starts at a massive radio telescope, which is just recording these raw signals from space. Then, that huge amount of data gets broken down into these small, manageable chunks called work units. Next, these little work units were sent out over the internet to people like you and me. Your home PC would then do all the heavy lifting, all the analysis. And finally, if it thought it found something, a little report would get sent back to a central database for the scientists to double-check. So what exactly were all these millions of computers actually looking for? Well, they were programmed to be digital detectives, really, hunting for very specific clues that would prove a signal wasn't just random cosmic noise. Okay, so one of the absolute biggest clues they're looking for is something called Doppler drift. It's just like how an ambulance siren changes pitch as it comes towards you and then moves away. Any radio signal from a planet that's spinning on its axis or orbiting a star would be doing the same thing, constantly shifting in frequency. SETI at Home was built specifically to find these signals with that exact telltale drift. Now, the software was hunting for a few different kinds of signals, but we can basically boil them down to two main categories. First, you've got a spike. Think of this as a continuous, steady tone at one single frequency, kind of like a cosmic dial tone. And second, you've got a pulse, which is a signal that blips on and off with a really regular rhythm. Finding either one of those, especially with the right kind of Doppler drift, would be a very big deal. And the response from the public? I mean, it was just absolutely staggering. People from literally every corner of the globe downloaded the software. They turned their home computers into pieces of a single planet-sized scientific instrument. Just think about this for a second. At its peak, the project had over 1 million active volunteers. It grew to become one of the largest collaborative science experiments in human history, all of it powered by our shared fascination with that one huge question. And all that combined computing power, it was mind-blowing. By 2020, the entire network was performing 600 trillion calculations every single second. To put that into perspective for you, that's a level of power that rivaled and sometimes even beat some of the most powerful supercomputers on Earth. And the project's run was just incredible, right? We're talking 21 years. It kicked off back in 1999. It evolved over time by moving to the Boeing platform, which helped expand this whole model to other scientific projects, and it got a massive boost by using the power of modern GPUs. Then, in 2020, the project finally stopped sending out new data to focus on the next huge task, analyzing all the results that volunteers had sent back over the years. Okay, this all sounds amazing in theory, but you gotta ask the big question, right? Could this massive, decentralized network of totally normal computers actually work? Could it reliably find a real artificial signal coming from space? And the answer was this huge, resounding yes.
As the ultimate test, scientists pointed a telescope right at the Voyager 1 spacecraft, the most distant object we've ever sent out. They fed that data into the SETI at home network, and it worked perfectly. Millions of home computers correctly identified that faint drifting signal from the very edge of our solar system. The concept was proven. It worked.
So even though SETI at home isn't sending out new data anymore, its legacy is just enormous. It didn't just search the stars, it completely changed how we can approach doing science, period. And this table right here, this really shows you the project's secret sauce. Sure, it had high sensitivity over a huge patch of sky, but the real key is that last column. It had the ability to search for signals with a very, very wide range of Doppler drift rates. And what that means is it could potentially find signals from planets spinning much faster or much slower than our own, exactly the kinds of weird signals that other, more narrow searches would have completely missed. So when you boil it all down, what's the real legacy here? Well, SETI at home proved that you can create a global supercomputer using nothing but volunteer PCs. It pioneered brand new techniques to find those super faint, drifting signals. It was the very first project of its kind to look for really complex patterns. And maybe most important of all, it created one of the biggest collaborative science experiments in history, bringing millions of us right into the heart of scientific discovery. So look, while no alien signal has been confirmed, the work is far from over. Scientists are now digging through 20 years of collected data of all those potential detections, looking for that one signal that just stands out. Which kind of leaves us with one final, really tantalizing thought. After all this time and all this work, could the answer, the needle in the cosmic haystack, have already been found, just sitting there in the data, waiting for someone to finally notice it?